David space Malan, enter, and I think the output looks pretty good. It looks as expected grammatically. Let me now go ahead, though, and play this game again, but this time maybe because I'm not thinking or I'm just in the habit of doing last name, comma, first, I do Malan, comma, David, and hit enter. All right, well, this now is weird. Even though the program is just spitting out exactly what I typed in, arguably this is not close to correct, at least grammatically. It should really say, hello, David Malan. Now, maybe I could have some if conditions and I could just reject the user's input if they type a comma or get their names backwards somehow. But that's going to be too little too late if the user has already submitted a form online and I already have the data and now I need to go in and clean it up. And it's not going to be fun to go through manually in Google Spreadsheets or Apple Numbers or Microsoft Excel and manually fix a lot of people's names to get rid of the commas and move the first name before the last, as is conventional in the US. So let's do this. It could be a little fragile, but let's start to express ourselves a little programmatically here and ask this. If there is a comma in the person's name, which is Pythonic, I'm just asking the question, is this shorter string in this longer string? Then let me go ahead and do this. Let me go ahead and grab that name in the variable, split on not just the comma, but the space after, assuming the human typed in a space after their name. And let me go ahead and store the result of that splitting of Malan, comma, David into two variables. Let's do last, comma, first. Again, unpacking the sequence of values that comes back. Now, let me go ahead and reformat the name. So I'm going to forcibly change the user's name to be as I expect. So name is actually going to be this format string. First name, then last name, both in curly braces, but formatted together with a single space so that I'm overriding the user's input and updating my name variable accordingly. For the moment, to be clear, this program is interactive. Like the users, like me, are typing their name into the program. But imagine the data already is in a CSV file. It came in from some process like a Google form or something else online. You could imagine writing code similar to this, but that maybe goes and reads that file into memory first. Maybe it's a CSV via a CSV reader or dict reader, and then iterating over each of those names. But we'll keep it simple and just do one name at a time. But now what's kind of interesting here is if I go back to my terminal window and clear it and run Python of format.py and hit enter, I'm going to type in David space Malan as before, and I think we're still good. But I'm also going to go ahead and do this. Python of format.py, Malan, comma, David, with a space in between, crossing my fingers and hit enter, and voila. That now has been fixed. Such a simple thing, to be sure, but it is so commonly necessary to clean up users' input. Here we see at least one way to do so pretty easily. Now, to be fair, there's some problems here. And in fact, can someone imagine a scenario in which this code really doesn't fix the user's input? What could still go wrong even with this fix in my code? Any thoughts?
If they type in their name, comma, and then sign them.
Oh, and then something else. Yeah, so let me try this, for instance. Let me go ahead and run a program. And I am the only David Malan that I know. But suppose I were, let's say, Junior, like this. And it's common in English, at least, to sometimes put a comma there. You don't necessarily need the comma. But I'm one of those people who uses a comma. That's now really, really broken. So I've broken some assumption there. And so that could certainly go wrong here. What else? Well, let me go ahead and run this again. And if I did Malan, comma, David, no space, because I'm being a little sloppy, I'm not paying attention, which is going to happen when you have lots of users ultimately. Well, this really broke now. Notice I have a value error, an actual exception. Why? Well, because split is supposed to be splitting the string into two strings by looking for the comma and a space. But if there is no comma and space, it can't split it into two things. And the fact that I have two variables on the left, but I'm only getting back one thing on the right means that I can't do this code quite as this. So it's fragile to be sure, but wouldn't it be nice if we could at least improve it? For instance, we now know some regular expression syntax. What if I at least wanted to make this space optional? Well, I could use my newfound regular expression syntax and put a question mark. Question mark means 0 or 1 of the things to the left. What's the thing to the left? It's literally a space. I don't even need parentheses if there's just one thing there. So that would be the start of a pattern that says I must have a comma, and then I may or may not have a space, 0 or 1 spaces thereafter. Unfortunately, the version of split that's built into the stir variable, as in this case, doesn't support regular expressions. If we want our regular expressions, we need to go use that library here. So let me go ahead and do this. Let me go in and leave this code as is, but go up to the top now and import RE to import the library for regular expressions. And now let me go ahead and start changing my approach here. I'm going to go ahead and do this. I'm going to use the same function called re.search, and I'm going to search for a pattern that I think will be last comma first. So let me use my newfound regular expression syntax and represent a pattern for something like Mahlon, comma, space David. How can I do this? Well, inside of my quotes for re.search, I'm going to have something, so I'm going to have something, so dot plus. Then I'm going to have a comma. Then I'm going to have a space. Then I'm going to have something dot plus. Now I'm going to preemptively refine this a little bit. I want this whole pattern to start matching at the beginning of the user's input, so I'm going to add the caret right away. And I want the end of the user's input to be matched as well, so that I'm literally expecting any character one or more times, then a comma, then a space, then any other character one or more times. And then that is it. And I'm going to pass in the name variable as before. Now, when we've used re.search in the past, we really used it just to answer a question. Does the user's input match the following pattern or not, true or false, effectively? But re.search is actually more powerful than that. You can actually get back more information, and you can do this. You can specify a variable and then an assignment operator and get back more precise answers to what has been found when searched for. But what is it you want to get back? Well, it turns out there's this other feature of regular expressions which allow you to use parentheses not just to group things together, but to capture them. It turns out when you specify parentheses in a regular expression, unbeknownst to us up until now, everything in the parentheses will be returned to you as a return value from the re.search function. It's going to allow you to extract specific amounts of information from the user's own input. You can reverse this process, too, by using the non-capturing version as well. You can use parentheses and then literally a question mark and a colon and then some other stuff, and that will say, don't bother capturing this. I just want to group things. But for now, we're going to use just the parentheses themselves. So how am I going to do this? Well, if I want to get back the user's last name and first name, I think what I want to capture is the dot plus here and the dot plus here. So I've deliberately surrounded in parentheses the dot plus, both to the left and the right of the comma, not because I'm grouping them together per se. I'm not adding a question mark. I'm not adding up another plus or a star. I'm using parentheses now for capturing purposes. Why? Well, I'm going to do this next. I'm going to still ask a Boolean question, like if there are matches, then do this. So if matches is not effectively false, like none, I do expect I've gotten back some matches. And watch what I can do now. I can do last comma first equals whatever matches in and get back all of the groups of matches. Then go ahead and update name just like before with a format string and do first and then last in curly braces as well. And then at the very bottom, just like before, print out, for instance, hello, comma, name. So the new code now is everything highlighted here. I'm using re.search to search for whether the user typed their name in last comma first format. But I am more powerfully using re.search to capture some of the user's input. What's going to get captured? Anything I surrounded in parentheses will be returned to me as return values. How do you get at those return values? You ask the variable to which you assigned them for all of the groups of parentheses that were captured. So let me go ahead and do this. Let me go ahead now and run Python of format.py, enter, and I'm going to type my name as usual. In this case, nothing happens with this if condition. Why? Because I did not type a comma, and so this search does not find a comma, so there are no matches. So we immediately just print out hello name. Nothing interesting or new there. But if I now go ahead and clear my screen and run Python of format.py and do Mahlon, comma, space David, enter, we've reformatted my name. Well, how did this work? Let me be a little more explicit now. It turns out I don't have to just say matches.groups. I can get specific groups back that I want. So let me change my code a little bit more. Let me go ahead now and just say this. Let's update name well, actually, let's do this. Let's say that the last name is going to be in the matches, but specifically group 1. The first name is going to be in the matches, but specifically group 2. Why 1 and 2? Because this is the first set of parentheses to the left of the comma. This is the second set of parentheses to the right of the comma. And based on the input, this would be the user's last name in this scenario, Malin. This would be the user's first name, David, in this scenario. That's why I'm using group 1 for the last name and group 2 for the first name. And now I'm going to go ahead and say name equals f string again, first and then last, done. And let me refine this one last step before we take questions. I don't really need these variables if I'm immediately using them. Let's just go ahead and tighten this up further, as we've done in the past for design's sake. If I want to make the name the concatenation of the person's first name and last name, let's just do this. Matches.group2 first plus a space plus matches.group1. So it's just up to me to know from left to right, this is group 1, this is group 2. So group 1 is last, group 2 is first. So if I want to flip them around and update the value of name, I can explicitly get group 2 first, concatenate using plus a single space, and then concatenate on group 1. All right, that was a lot. Let me pause to see if there are questions. The key difference here is we're still using re.search the exact same way, but now I'm using its return value, not just to answer a question true or false, but to actually get back specific matches, anything I captured, so to speak, with parentheses.
Why is it here we're using 1 and 2 instead of 0 and 1?
A really good question.
Capturing the first.
A good observation. In almost every other context, we've started counting at 0 and 1 instead of 1 and 2. It turns out there's something else in location 0 when it comes back from re.search related to the string itself. So according to the documentation of this function only, 1 is the first set of parentheses and 2 is the second set, and onward from there. Just a different convention here. Other questions?
What if we write nothing, like white space, comma, white space? How we check true of condition?
Before I answer directly, let me just run this and make sure I've not broken anything further. Let me run python to format.py. Let me type in David space Malin the right way. Let me run it once more. Let me type in Malin comma David the wrong way that we're fixing, and we're still good. But I think it will still break. Let me run it a third time with Malin comma David with no space. And now it's still broken. Why? Because I'm still looking for comma space. Now, how can I fix that? One way I could do that is to add a question mark here, which again is 0 or more of the thing before. So if I have a space and then a question mark literally, no need for any parentheses, then I can literally tolerate both Malin comma space David or Malin comma David. So let's try again. Before this did not work. Let's do Malin comma David with no space. Now it does actually work. So we can tolerate different amounts of white space if I am a little more precise with my formula. Let me go ahead and try once more. Let me very weirdly, but possibly, hit the spacebar a few too many times. So now they're really separated. This again is not going to work quite right because it's going to consume all of that white space. So now I might want to strip left and right any of the leading white space on the result. Or what I could do here is say this. Instead of 0 or 1, I could use a star here. So space star. And now if I run this once more with Malin comma space 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 David, enter, now we've cleaned up things further. So you can imagine, depending on how messy the data is that you're cleaning up, your regular expressions might need to get more and more sophisticated. It really depends on just how many problems we want to solve at once. Well, allow me to propose that we forge ahead further just to clean this up even more so using a feature that's actually relatively new to Python itself. It is very common when using regular expressions to do exactly what I've done here, to call a function like re.search with capturing parentheses inside such that you get back a return value that I'm calling matches. You could call it something else, but I'm calling it by default matches. And then notice on the next line, I'm saying if matches. Wouldn't it be nice if I could just tighten things up further and do these all on the same line? Well, you can sort of. Let me go ahead and do this. Let me get rid of this if. And let me just try to say something like this. If matches equals research and then colon. So combining my if condition into just one line instead of those two. In C or C++ or Java, you would actually do something like this, surrounding the whole thing with parentheses, sometimes double sets to suppress any warnings, if you want to do two things at once. If you want to not only assign the return value of re.search to a variable called matches, but you want to subsequently ask a Boolean question. Is this effectively true or false? That's what I was doing a moment ago. Let me undo this. A moment ago, I was getting back the return value and assigning it to matches, and then I was asking the question. Well, it turns out this need to have two lines of code presumably rubbed people wrong for too long in Python, and so you can now combine these two kinds of lines into one, but you need a new operator. You cannot just say if matches equals research and then a colon at the end. You instead need to do this. You need to do colon equals if and only if you want to assign something from right to left, and you want to ask an if or an elif question on the same line. This is affectionately known, as you can see here, as the walrus operator. And it's new to Python in recent years. And it both allows you to assign a value, as I'm doing, from right to left, and ask a Boolean question about it, like I'm doing with the if or equivalently elif. Does anyone know why this is called the walrus operator? If you kind of look at it like this, perhaps, if you're familiar with walruses, it kind of sort of looks like a walrus. So a minor detail, but a relatively new feature of Python that honestly you'll probably continue to see online and in source code and in textbooks and so forth, increasingly so now that it does exist. It does not change the logic at all. If I run python of format.py and type Malan, comma, space David, it still fixes things, but it's tightened up my code just a bit more. All right, let's go ahead and look at one final problem to solve, that of extracting information now as well. So at this point, we've now validated the user's input by checking whether or not it meets a certain pattern. We've cleaned up the user's input by checking against a pattern whether it matches or not. And if it does match, we kind of reorganize some of the user's information so we can clean up their input and standardize the format in which we're storing or printing it in this case. Let's do one final example where we're very specifically extracting information in order to answer some question. So let me propose this. Let me go ahead and close format.py and create a new file called twitter.py. The goal of which is to prompt users for the URL of their Twitter profile and extract from it, infer from that URL, what is the user's username. Now, why might you want to do this? Well, one, you might want users to be able to just very easily copy and paste the URL from their own Twitter profile into your form, into your app, so that you can figure out what their username is. Or you might have a form that asks the user for their Twitter username. And because people aren't necessarily paying very close attention, some people type their username. Some people type their whole URL or something else altogether. It would be nice, now that you're a programmer, to just be more tolerant of different types of input and just take on the burden of canonicalizing, standardizing the data, but being flexible with the users. It's arguably a better user experience if you just let me copy paste or type in what I want. You clean it up. You're the programmer, not me. Lens for a better experience, perhaps. Well, let me go ahead and do this with twitter.py. Let me first go ahead and prompt the user here for a value for a variable that I'll call URL, and just ask them to input the URL of their Twitter profile. I'm going to go ahead and strip off any leading or trailing white space, just in case users accidentally hit the spacebar. That's like literally the least I can do quite easily. But now let's go ahead and do this. Suppose that the user's address is the following. Let me print out what they type in, and let me clear my screen and run python of twitter.py. I'm going to go ahead and type in, for instance, https://twitter.com/DavidJMalan, which happens to be my own Twitter username. For now, we're just going to print it back onto the screen just to make sure I've not messed up yet. OK, so I've printed back out the exact same URL, but the goal at hand is to extract the username only. Now, let me just ask perhaps a straightforward question. Logically, what do I need to do to get at the user's username?
Well, we just ignore what's before the username and then just extract the username.
Perfect. Yeah, I mean, it is as simple as that. If you know the username's at the end, well, let's just somehow ignore everything to the beginning. Well, what's at the beginning? Well, it's a URL. So we're probably going to need to ignore an HTTPS, a : / a twitter.com, and a slash. So we just want to throw all of that away. Why? Because if it's a URL, we know by how Twitter works that the username comes at the end. So let's use that very simple idea to get at the information we want. Well, I'm going to try this a few different ways. Let me go back into my program here, and instead of just printing it out, which was just to see what's going on, let me do this. Let me create a new variable called username, and let me call url.replace. It turns out that if URL is a string or a str in Python, it again comes with multiple methods like strip and split and others as well, one of which is called replace. And replace will do just that. You pass it 2 arguments, the first of which is what do you want to replace? The second argument is what do you want to replace it with? So if I want to get rid of, as Ivan proposed, really just everything before the username, that is the Twitter URL or the beginning thereof, let's just say this. Go ahead and replace https : / twitter.com / close quote. That's what I want to replace. And comma, second argument, what do you want to replace it with? Nothing. So I'm literally going to pass in quote unquote to effectively do a find and replace. That's what the replace method does, just like you can do it in Microsoft Word or Google Docs. This is the programmer's way of doing find and replace. Now, let me go ahead and print out just the username. So I'll use an F string like this. I'll say username : and then in curly braces username, just to format it nicely. All right, let me go ahead and clear my screen and run Python of twitter.py, enter URL. Here we go, https : / twitter.com / David J. Malan, enter. OK, now we've made some progress. Done for the day, right? Well, what is suboptimal about this? Can anyone critique or find fault with my program? It is working now, but it's a little fragile. I bet we could contrive some scenarios where I think it works, but it doesn't.
Well, I have a few ideas, actually. Well, first of all, if we don't specify HTTPS, it will be broken. Secondly, if we have slash at the end, it also will be broken. If we have like question mark or something after question mark, it also won't work. So a lot of scenarios, actually.
Oh my God. I mean, here we are. I was pretending to think I was done, but my God, like Alex gave us a whole laundry list of like problems. And just to recap then, what if it's not HTTPS, it's HTTP? Slightly less secure, but I should still be able to tolerate that programmatically. What if the protocol's not there? What if the user just typed twitter.com / David J. Malan? It would be nice to tolerate that rather than show an error and make me type in the protocol why. It's not good user experience. What if it had a slash at the end of the username or a question mark? If you think about URLs you've seen on the web, there's very commonly more information, especially if it's been shared on social media. There might be HTTP parameters, so to speak, just stuff there that we don't want. There could be a www.twitter.com, which I'm also not expecting, but does work if you go to that URL too. So there's just so many things that can go wrong. And even if I come back to my contrived example as earlier, what if I run this program and say this? My username is https : / twitter.com / David J. Malan, enter. Well, that too just didn't really work. It got rid of the URL. Actually, OK, actually that kind of worked. But the goal here is to actually get the user's username, not an English sentence describing the user's username. So I would argue that even though I just accidentally created perfectly correct English grammar, I did not extract the Twitter username correctly. I don't want words like my username is as part of my input. So how can we go about improving this and maybe chipping away at some of those problems one by one? Well, let me clear my screen here. Let me come back up to my code and let me not just replace it, but let me do something else instead. I'm going to go ahead and instead of using replace, I'm going to use another function called remove prefix. A prefix is a string or a substring that comes at the start of another. So if I remove prefix, I don't need a second argument for this function. I just need one. What prefix do you want to remove? So this will at least now fix the problem I just described of typing in like a whole sentence where the URL is there, but it's not at the beginning, it's only at the end. So here, this still is not correct, but we don't create this weird looking output that just removes the URL part of the input. My username is https://twitter.com/DavidJMalin. A moment ago, it did remove the URL and left only the David J. Malin. This is not perfect still, but at least now it does not weirdly remove the URL and then leave the English. It's just leaving it alone. So maybe I could handle this better, but at least it's removing it from the part of the string I might anticipate. Well, what else could we do here? Well, it turns out that like regular expressions just let us express patterns much more precisely. We could spend all day using a whole bunch of different Python functions like remove prefix or remove and strip and others and kind of make our way to the right solution. But a regular expression just allows you to more succinctly, if admittedly more cryptically, express these kinds of patterns and goals. And we've seen from parentheses, which can be used not just to group symbols together as sets, but to capture information as well, we have a very powerful tool now in our toolkit. So let me do this. Let me go ahead and start fresh here and import the RE library as before at the very top of my program. I'm still going to get the user's URL via the same line of code, but I'm now going to use another function as well. It turns out that there's not just re.search or re.match or re.fullmatch. There's also re.sub in the regular expression library, where sub here means substitute. And it takes more arguments, but they're fairly straightforward. The first argument to re.sub is the pattern, the regular expression that you want to look for. Then you have a replacement string. What do you want to replace that pattern with? And where do you want to do all that? Well, you pass in the string that you want to do the substitution on. Then there's some other arguments that I'll wave my hands at for now. Among them are those same flags and also a count, like how many times do you want to do find and replace? Do you want it to do all? Or do you want to do it just one? Or so forth. You can have further control there too, just like you would in Google Docs or Microsoft Word. Well, let me go back to my code here. And let me do this. I'm going to go ahead and call re, not search, but re.sub for substitute. I'm going to pass in the following regular expression, https://twitter.com/ and then I'm going to close my quote. And now what do I want to replace that with? Well, like before, with the simple stir replace function, I want to replace it with nothing. Just get rid of it altogether. But what string do I want to pass in to do this to? The URL from the user. And now let me go ahead and assign the return value of resub to a variable called username. So resub's purpose in life is, again, to substitute some value for some regular expression some number of times. It essentially is find and replace using regular expressions. And it returns to you the resulting string once you've done all those substitutions. So now the very last line of my code can be the same as before, print, and I'll use an F string, username, colon, and then in curly braces, username. So I can print out literally just that. All right, let's try this and see what happens. I'll clear my terminal window, run python of twitter.py, and here we go. https://twitter.com/DavidJMalin. Cross my fingers and hit enter. OK, now we're in business. But it is still a little fragile. And so let me ask the group, what problems should I now further chip away at? They've been said before, but let's be clear. What's one or more problems that still remain?
The protocols and the domain prefixes po.
Good, the protocol, so HTTP versus HTTPS. Maybe the subdomain, www, should it be there or not? And there's a few other mistakes here too. Let me actually stay with the group. What are some other shortcomings of this current solution?
If we use a phrase like you do before, we are going to have the same problem because it's not taking account in the first part of the text example.
Good. I might still allow for like some words, some English to the left of the URL because I didn't use like my caret symbol. So I'll fix that. And any final observations on shortcomings here?
It could be a HTTP, or there could be like less than 2 slashes.
OK, so it could be HTTP, and I think that was mentioned too in terms of protocol. There could be fewer than 2 slashes. That I'm not going to worry about. If the user gives me 1 slash instead of 2, that's really user error, and I could be tolerant of it, but you know what? At that point, I'm okay yelling at them with an error message saying, please fix your input. Otherwise, we could be here all day long trying to handle all possible typos. For now, I think in the interest of usability or user experience, UX, let's at least be tolerant of all possible valid inputs or reasonable inputs, if you will. So let me go here and let me start chipping away at these here. What are some problems we can solve? Well, let me propose that we first address the issue of matching from the beginning of the string. So let me add the caret to the beginning. And let me add not a $sign at the end, though, right? Because I don't want to match all the way to the end because I want to tolerate a username there. So I think we just want the caret symbol there. There's a subtle bug that no one yet mentioned. And let me just kind of highlight it and see if it jumps out at you now. It's a little subtle here on my screen. I've highlighted in blue a final bug here. Maybe some smiles on the screen. Yeah, can we take one hand here? Why am I highlighting the dot in twitter.com, even though it definitely should be there?
So the dot without a backslash mean any character is of a new line?
Yeah, exactly. It's not. It means any character. So I could type in something like Twitter .com or Twitter anything.com, and that would actually be tolerated. It's not really that bad because why would the user do that? But if I want to be correct and I want to be able to test my own code properly, I should really get this detail right. So that's an easy fix too, but it's a common mistake. Anytime you're writing regular expressions that happen to involve special symbols, like dots in a URL or domain name, a $sign in something involving currency, remember you might indeed need to escape it with a backslash like this here. All right, let me ask the group about the protocol specifically. HTTPS is a good thing in the world. It means secure. There is encryption being used, so generally you like to see HTTPS, but you still see people typing or copy-pasting HTTP. What would be the simplest fix here to tolerate, as has been proposed, both HTTP and HTTPS? I'm going to propose that I could do this. I could do HTTP vertical bar or HTTPS, which again means A or B, but I think I can be smarter than that. I can keep my code a little more succinct. Any recommendations here for tolerating HTTP or HTTPS?
We could try to put a question mark behind the S.
Perfect. Just use a question mark, right? Both of those would be viable solutions. If you want to be super explicit in your code, fine. Use parentheses and say HTTP or HTTPS so that you, the reader, your boss, your teacher, just know exactly what you're doing. But you know, if you keep taking the more verbose approach all the time, it might actually become less readable, certainly once your regular expressions get this big instead of this big. So let's save space where we can. And I would argue that this is pretty reasonable. So long as you're in the habit of reading regular expressions and know that question mark does not mean a literal question mark, but it means 0 or 1 of the thing before, I think we've effectively made the S optional here. Now, what else can I do? Well, suppose we want to tolerate the www dot, which may or may not be there, but it will work if you go to a browser. I could do this, www dot, wait, I want a backslash there, so I don't repeat the same mistake as before, but this is no good either because I want to tolerate www being there or not being there. And now I've just required that it be there, but I think I can take the same approach. Any recommendations? How do I make the www dot optional, just to hammer this home?
We can like group, make a square and question mark.
Perfect. So question mark is the short answer again, but we have to be a little smarter this time. As Maria's noted, we need parentheses now, because if I just put a question mark after the dot, that just means the dot is optional. And that's wrong, because we don't want the user to type in www.twitter. We want the dot to be there, or just not at all with no www. So we need to group this whole thing together. Put a parenthesis there, and then a parenthesis not after the third W, after the dot, so that that whole thing is either there or it's not there. And what else could we still do here? You know, there's going to be one other thing we should tolerate, and it's been said before, and I'll pluck this one off. What about the protocol? Like, what if the user just doesn't type or doesn't copy paste the HTTP : or an HTTPS : right? Honestly, you and I are not in the habit generally of even typing the protocol anymore nowadays. You just let the browser figure it out for you and automatically add it instead. So this one's going to look like more of a mouthful, but if I want this whole thing here in blue to be optional, it's actually the same solution as Maria offered a moment ago. I'm going to go ahead and put a parenthesis over here and a parenthesis after the 2 slashes and then a question mark, so as to make that whole thing optional as well. And this is OK. It's totally fine to make this whole thing optional, or inside of it, this little thing, just the S, optional as well. So long as I'm applying the same principles again and again, either on a small scale or a bigger scale, it's totally fine to nest one of these inside of the other. Questions now on any of these refinements to this parsing, this analyzing of Twitter?
What if we put a vertical bar besides this www.
What if we use a vertical bar there? So we could do something like that too. We could do something like this. Instead of the question mark, I could do www dot or nothing and just leave that in the parentheses. That too would be fine. I personally tend not to like that because it's a little less obvious to me. Wait a minute, is that deliberate, or did I forget to finish my thought by putting something after the vertical bar? But that too would be allowed there as well, if that's what you mean. Other questions on where we left things here, where we made the protocol optional too?
What would happen if we have parentheses, and then inside we have another parenthesis and another parenthesis? Would it interfere with each other?
If you have parentheses inside of parentheses, that too is totally fine. And indeed, that should be one of the reassuring lessons today. As complicated as each of these regular expressions has admittedly gotten, I'm just applying the exact same principles and the exact same syntax again and again. So it's totally fine to have parentheses inside of parentheses if they're each solving different problems. And in fact, the lesson I would really emphasize the most today is that you will not be happy if you try to write out a whole complicated regular expression all at once. Like if you're anything like me, you will fail and you will have trouble finding the mistake because, my God, look at these things. They are, even to me all these years later, cryptic. The better way, I would argue, whether you're new to programming or as old to it as I am, is to just take these baby steps, these incremental steps where you do something simple, you make sure it works. You add one more feature, make sure it works. Add one more feature, make sure it works. And hopefully by the end, because you've done each of those steps one at a time, the whole thing will make sense to you, but you'll also have gotten each of those steps correct at each turn. So please do avoid the inclination to try to come up with long, sophisticated regular expressions all at once, because it's just not a good use of a time if you then stare at it trying to find a mistake that you could have caught if you did things more incrementally instead. All right, there still remains arguably at least one problem with this solution, in that even though I'm calling re.sub to substitute the URL with nothing, quote unquote, I then, on my final line of code, line 6, am just blindly assuming that it all worked. And I'm going to go ahead and print out the username. But what if the user, if I clear my screen here and run python of twitter.py, doesn't even type a Twitter URL? What if they do something like https://www.google.com/, like completely unrelatedly, for whatever reason, enter, that is not their Twitter username. So we need to have some conditional logic, I would argue, so that for this program's sake, we're only printing out, or in a back-end system, we're only saving into our database or a CSV file the username if we actually matched the proper pattern. So rather than use re.sub, which is useful for cleaning up data, as we've done here to get rid of something we don't want there, why don't we go back to re.search, where we began today, and use it to solve the same problem, but in a way that's conditional, whereby I can confidently say yes or no at the end of my program. Here's the username, or here it is not. So let me go ahead now, and I'll clear my terminal window here. I'm going to keep most of I'm going to keep the first two lines the same, where I import re and I get the URL from the user. But this time, let's do this. Let's this time search for, using re.search instead of re.sub, the following. I'm going to start matching at the beginning of the URL of the string, https question mark to make the S optional, ://. Then I'm going to make my www optional by putting that in question marks there. Then a twitter.com with a literal dot there, so I'll stay ahead of that issue too. Then a slash, and then, well, this is where David J. Malin is supposed to go. How do I detect this? Well, I think I'll just tolerate anything at the end of the URL here. All right, $sign at the very end, close quote. For the moment, I'm going to stipulate that we're not going to worry about question marks at the end or hashes, like for fragment IDs and URLs. We're going to assume for simplicity now that the URL just ends with the username alone. Now, what am I going to do? Well, I want to search for this URL specifically, and I'm going to ignore case. So re.ignore case, applying that same lesson learned from before. re.search recall will return to you the matches you've captured. Well, what do I want to capture? Well, I want to capture everything to the right of the twitter.com URL here. So let me surround what should be the user's username with parentheses. Not for making them optional, but to say capture this set of characters. Now, re.searchRecall returns an answer. Matches will be my variable name again, but I could call it anything I want. And then I can do this. If matches, now I know I can do this. Let's print out the format string username colon, and then what do I want to print out? Well, I think I want to print out matches.group1 for my matched username. All right, so what am I doing just to recap? Line 1, I'm importing the library. Line 2, I'm getting the URL from the user, so nothing new there. Line 5, I'm searching the user's URL, as indicated here as the second argument, for this regular expression, this pattern. I have surrounded the dot plus with parentheses so that they are captured ultimately. So I can extract in this final scenario the user's username. If I indeed got a match, and matches is none, it is actually containing some match, then and only then print out username. In this way, let me try this now. If I run python of twitter.py and type in https://www.google.com/, now nothing gets printed. So I've at least solved the mistake we just saw where I was just assuming that my code worked. Now I'm making sure that I have searched for and found the Twitter URL prefix. All right, well, let's run this for real now. Python of twitter.py, https://twitter.com/DavidJMalin. But note, I could use HTTP. I could use www. I'm just going to go ahead here and hit enter. Huh, none. What has gone wrong? This one's a bit more subtle. But why does matches.group1 contain nothing? Wait a minute. Maybe I did this wrong. Maybe do we need the www? Let me run it again. So here we go. https:// let's add it. www.twitter.com/DavidJMalin. All right. Enter. Ho ho ho. What is going on?
You have to say it's group 2.
I have to say group 2. Well, wait, oh, right, because we had the subdomain was optional, and to make it optional, I needed to use parentheses here, and so I then said 0 or 1. Okay, so that means that actually I'm unintentionally, but by design, capturing the www dot, or none of it if it wasn't there before, but I have a second match over here because I have a second set of parentheses. So I think, yep, let me change matches group 1 to matches group 2, and let's rerun this. Python of twitter.py, https://www.twitter, let's do this, twitter.com/DavidJMalin, enter, and now we've got access to the username. Let me go ahead and tighten it up a little bit further. If you like our new friend, it's hard not to like. If we like our old friend, the walrus operator, let's go ahead and add this just to tighten things up. Let me go back to VS Code here, and let me get rid of the unnecessary condition there and combine it up here. If matches equals that, but let's change the single assignment operator to the walrus operator. Now I've tightened things up further, but I bet there might be another solution here. And indeed, it turns out that we can come back to this final set of syntax. Recall that when we introduced these parentheses, we did it so that we could do A or B, for instance, with the vertical bar, though you can even combine more than just one bar. We used the group to combine ideas like the www dot, and then there's this admittedly weird syntax at the bottom here, up until now not used. There is a non-capturing version of parentheses if you want to use parentheses logically, because you need to, but you don't want to bother capturing the result. And this would arguably be a better solution here because, yes, if I go back to VS Code, I do need to surround the www dot with parentheses, at least as I've written my regex here, because I wanted to put the question mark after it. but I don't need the www dot coming back. In fact, let's only extract the data we care about just so there's no confusion down the road for me or my colleagues or my teachers. So what could I do? Well, the syntax per this slide is to use a question mark and a colon immediately after the open parenthesis. It looks weird, admittedly. Those of you who have prior programming experience might recognize the syntax from ternary operators, doing an if-else all in one line. A question mark colon at the beginning of that parenthetical means, yes, I'm using parentheses to group these things together, but no, you do not need to capture them instead. So I can change my code back now to matches.group1. I'll clear my screen here, run python of twitter.py. I'll again run here https://twitter.com/davidjmalin with or without the www. And now I indeed get back that username. Any questions then on these final techniques?
So first of all, could we move the caret right at the beginning of Twitter and then just start from reading from there and then get rid of everything else before that, the kind of www issues that we had? And then my second question is, how would we use kind of, I guess, either a list or a dictionary to sort the .com kind of thing, because we have .co.uk and that kind of stuff. How would we bring that into the RE function?
A good question, but no. If I move the caret before twitter.com and throw away the protocol and the www, then the user is going to have to type in literally twitter.com/username. They can't even type in that other stuff, so that would be a regression, a step back. As for the .com and the .org and .edu and so forth, the short answer is there's many different solutions here. If I wanted to be stringent about .com, and suppose that Twitter probably owns multiple domain names, even though they tend to use just this one. Suppose they have something like .org as well. You could use more parentheses here and do something like this, com or org. I'd probably want to go in and add a question mark colon to make it non-capturing, because I don't care which it is. I just want to tolerate both. Alternatively, we could capture that. We could do something like this, where we do +, so as to actually capture that. And then we could do something like this. If matches.group1 now equals com, then we could support this. So you could imagine factoring out the logic just by extracting the top-level domain, or TLD, and then just using Python code, maybe a list, maybe a dictionary, to validate elsewhere outside of the regex if it's in fact what you expect. For now, though, we kept things simple. We focused only on the .com in this case. Let's make one final change to this program so that we're being a little more specific with the definition of a Twitter username. It turns out that we're being a little too generous over here, whereby we're accepting one or more of any character. I checked the documentation for Twitter, and Twitter only supports letters of the alphabet, A through Z, numbers 0 through 9, or underscore. So not just dot, which is literally anything. So let me go ahead and be more precise here. At the end of my string, let me go ahead and say this set of symbols in square brackets. I'm going to go ahead and say A through Z, 0 through 9, and an underscore, because again, those are the only valid symbols. I don't need to bother with an uppercase A or a lowercase z because we're using re.ignore case over here. But I want to make sure now that I tolerate not only one or more of these symbols here, but also maybe some other stuff at the end of the URL. I'm now going to be OK with there being a slash or a question mark or a hash at the end of the URL, all of which are valid symbols in a URL, but I know from the Twitter's documentation are not part of the username. All right, now I'm going to go ahead and run python of twitter.py one final time, typing in https://twitter.com/DavidJMalin. Maybe with, maybe without a trailing slash, but hopefully with my biggest fingers crossed here, I'm going to go ahead now and hit enter. And thankfully, my username is indeed David J. Malin. So what more is there in the world of regular expressions and this own library? Not just re.search and also re.sub. There's other functions too. There's re.split, via which you can split a string, not using a specific character or characters like a comma and a space, but multiple characters as well. And there's even functions like re.findAll, which can allow you to search for multiple copies of the same pattern in different places in a string so that you can perhaps manipulate more than just one. So at the end of the day now, you've really learned a whole other language, like that of regular expressions, and we've used them in Python. But these regular expressions actually exist in so many languages too, among them JavaScript and Java and Ruby and more. So with this new language, even though it's admittedly cryptic when you use it for the first time, you have this newfound ability to express these patterns that, again, you can use to validate data, to clean up data, or even extract data and from any data set you might have in mind. That's it for this week. We will see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on Object-Oriented Programming, or OOP. It turns out that in the world of programming, there's different paradigms of programming languages. There's different ways of solving problems with code, and it's a little hard to see this at first if you've only learned one language, but over time, if and when you learn other languages besides Python, you'll start to notice certain patterns and certain capabilities of some languages, but not another. Thus far, within the world of Python, you and I have largely been writing code that's procedural in nature, whereby we're writing procedures, we're writing functions, and we're sort of doing things top to bottom. Everything is step by step by step, as you would expect in general from an algorithm. But along the way, we've actually dabbled in another paradigm known as functional programming with Python, whereby we've been able to pass functions around. We even had an anonymous function some weeks ago, and that's evidence of features of a functional programming language, even though we've just scratched the surface thereof. Today, we focus on another paradigm, and this one in more detail, namely object-oriented programming. And now, while some of you might have prior programming experience and have learned languages like Java, which are by design fundamentally object-oriented, Python indeed allows you a bit of flexibility when it comes to how you solve problems with code. But it turns out OOP, object-oriented programming, is a pretty compelling solution to problems that you invariably encounter as your programs get longer, larger, and more complicated. So indeed, OOP, for our purposes, is going to be a solution to a problem that builds on so many of the lessons past. So let's go ahead and do this. Let's start by writing a program very procedurally by opening up VS Code here. I'm going to go ahead and create a program called student.py. And in this program, I want to do something relatively simple initially, as we might have done some weeks ago now, where I just ask a user for their name and, maybe in the context of the Harry Potter universe, their house, and just print out where that student is from. And let's gradually enhance this program by adding more and more features to it and see if we don't stumble upon problems that up until now we might not have had very elegant, well-designed solutions to. But if we introduce explicitly object-oriented programming as a programming technique, I bet we can clean up our code and set the stage for writing even more sophisticated programs, longer programs down the line. So in student.py, let me go ahead and do a name variable, setting it equal to the return value of input, and just prompt the user for their name like this. And then let me go ahead and do the same for a house variable and prompt the user for their house using input like this. And let's do something super simple now. Let's just go ahead and print out an F string that says something like name from house, just so that I can confirm that the contents of these variables are indeed as I expect. I'm not going to do any error checking or trimming or anything like that for now. I'm really just going to spit back out whatever the user just typed in. All right, let me go ahead and run Python of student.py. Let's use our go-to, like Harry, as in Harry Potter, from Gryffindor. And when I hit enter now, let's see if I see that Harry from Gryffindor is indeed the case. All right, so I think we have a working program at this point. But let's now introduce some of those lessons learned way back from week 0, where we started writing our own functions. Not necessarily because it solves the problem more correctly. I dare say this is correct as is, but it begins to give us building blocks that we can extend so as to solve more complicated programs. So let me go back up to student.py. And let's go ahead now and do this. Let's put the entire logic I just wrote inside of our typical method called main. And let me indent those 3 lines so that at least they're now combined into one main method. But instead of using input on line 2 and input on line 3, why don't we go ahead and assume for the moment that we've got some function called getName in the world. And let's go ahead and assume we've got another function like getHouse in the world that don't take parameters, but their purpose in life is, by their name, going to be to get the user's name and to get their user's house respectively. And then I'm going to print out the exact same f string as before. I, of course, need to implement these functions now. So let me go lower in my file and define a function called get_name. Nothing in these parentheses because it's not going to take a parameter. And I'm going to go ahead and do something like name equals input, quote unquote, name, just like before. And then I'm going to go ahead and return name. So it's a super simple function, but it's an abstraction. I now have a function called getName whose implementation details I don't have to care about anymore. I just know that the function exists. And I can tighten this up, in fact. I don't really need a name variable on line 8 if I'm immediately going to return that same name variable on line 9. So let me just tighten this up a little bit, even though it doesn't change the functionality, and just immediately return the return value of the inputs function call here. Let's do something very similar now for getHouse, which will similarly take no arguments. I'm going to go ahead and return the return value of input, this time prompting the user for their house. And I need one final detail at the very bottom. Let's continue our habit of doing if the name of this file equals quote unquote main, then let's go ahead and actually call main. And recall that we have that in place so that if this eventually becomes part of a module, a library of sorts, I don't accidentally call main blindly. I only do it if I mean to run main from the command line on this file. All right, so if I didn't make any mistakes here, let me go ahead and in my terminal window again run python of student.py, enter. Let's type in Harry, enter. Let's type in Gryffindor, enter. And we're set. Harry from Gryffindor seems to still be working. So we haven't really solved the problem any more correctly, but I've laid the foundation to maybe now do some more interesting things because I've had these building blocks in place. All right, but let me propose that we could be doing this a little bit differently. GetName, getHouse is fine, but at the end of the day, I'm really trying to get a student from the user. I want their name and their house, not just one or the other. So maybe it would be a little cleaner still to define a function called getStudent and let getStudent do all of this work for us. Now, theoretically, getStudent could call getName and could call getHouse, but because these functions are so short, I think I'm OK with just defining one function called getStudent that similarly won't take any arguments, but it's going to do two things. It's going to get the student's name by prompting them with input as before, and it's going to get the student's house by also prompting them as before. And then, now, I want to return the student, but I think I might have painted myself into a corner here because I now have two variables, name and house, and yet up until now, we've pretty much returned one or the other. We've returned one value. So any suggestions for how we can perhaps solve this problem that I just created for myself, whereby I want to return really a student, but I currently have a name variable and a house variable? I'd minimally like to return both of those.
I believe that we can return a dictionary, include the name and the house.
Yeah, so we absolutely could return a dictionary, a dict object in Python, whereby maybe one key is name, one key is house, and the values thereof are exactly the values of these variables. So we could totally do that. I worry that that might be getting a little complicated. I wonder if there's a simpler way instead. Any other instincts, even if you're not sure it would work?
Return both name and house.
Return both name and house. I like the sound of that. It sounds simple. I don't have to figure out what a dictionary is going to look like. And in fact, this too would be a valid approach, even if you've not seen this before. It turns out in Python that you can kind of return multiple values, but that's a bit of a white lie. Or we could take Mohammed's approach of actually returning a dictionary and putting multiple keys therein. So here again, we have yet another example of how you can solve the same problem in at least two ways. And I dare say we're about to see even more. So one way you could solve this problem, whereby you want to return multiple values, would be to do something like this. I could go ahead and literally return not just name, but I could put a comma and also return house. This is not necessarily something you can do in other languages if you have programmed in other languages before. It depends on the language. But it looks like, thanks to this comma, maybe I can, in fact, return two values as actually proposed. Well, if I'm returning two values in this way on line 10, How do I get both values at the same time? Well, there's a couple of ways. Let me go up to my main function. I know minimally I'm going to have to change the getName and getHouse to getStudent. But what am I going to store the return value in? I think I could actually do this. And we have seen this technique before where you can unpack, so to speak, sequences of values that are coming back. And indeed, consider this to be exactly that. Name, comma, house is some kind of sequence that I'm returning of values. Name, comma, house. So if I want to unpack those and store the return values in two separate variables, I can, in fact, use the commas on the left-hand side of my assignment operator, the equal sign, to do just that. Now, to be clear, I don't need to call these variables name and house here. I could simplify this and use just n here and h here, and then I could return just n and h. But I would argue that's not very clear to the reader as to what's going on. So I think in this case, even though it's a coincidence that I've used the same variable names in getStudent and getMain, and in main, it's a little more readable to someone like me. So I'm going to leave it as is. Well, let's go ahead and see now if this works. Let me clear my screen down here and run Python of student.py, enter. Let's again type in Harry. Let's again type in Gryffindor, enter. And voila, we still see that Harry is from Gryffindor. But what are we actually doing here? What are we actually doing by returning this value? Well, it turns out that what we've just done is used a tuple. A tuple is another type of data in Python that's a collection of values, x comma y or x comma y comma z. It's similar in spirit to a list in that sense, but it's immutable. It's not mutable. Now, what does that mean? A list, as we've seen it before, is a data structure in Python that you can change the values of. You can go into bracket 0 for the first location and change the value there. You can go to bracket 1, bracket 2, bracket 3, and actually change the values in lists. But if you have no intention of changing the values of variables and you want to return effectively multiple values, you don't have to even return it as a list. You can return it as a tuple instead, just by using a comma. And it turns out we can make explicit that here's the white lie. I'm not actually returning two values per se. Whenever you use a comma in this way on line 9, you're actually returning one value, which is a tuple. Inside of that tuple now are two values. So it's similar in spirit to returning one list with two things. Here I'm returning one tuple with two things. And the mere fact that I've used a comma and nothing else tells Python that I indeed want to return a tuple. But there's more explicit syntax that we can use instead. I can actually more verbosely put explicit parentheses around the values of this tuple just to make more clear to me, to the reader, that this isn't two values per se. This is one value with two things inside of it. And what I can actually do then, too, is I don't have to unpack this up here, so to speak. I can actually go up here and maybe give a more apt name like student. And I can name the value, or rather name the variable in which I'm storing the return value of getStudent as, quote unquote, student. So maybe this is a little better design now because I'm sort of abstracting away what a student is. It's implemented at the moment as a tuple with two values, but at least now I have a variable called what I mean, a student. But there's going to be a catch. On line 3, I still want to print out that student's name and their house, but I don't have a name variable anymore, and I don't have a house, and I also don't have a dictionary, as was proposed earlier, so I can't even go at those keys by name. But what a tuple is, it's very similar in spirit to a list, but it is indeed just immutable. And what I mean by that is I can still index into it numerically by saying student square bracket 0 for the item in the first location in that tuple. And then over here, instead of house, I can say student bracket 1. Student bracket 1 is going to give me the second location in that tuple. Let me go ahead and clear my terminal window. Again, run Python of student.py. Let's type in Harry. Let's type in Gryffindor, enter. And we still have some working code. Let me pause here now and see if there are any questions on this technique of returning a tuple and indexing into it in this way.
I guess what's a actual use case where you would use a tuple versus, a list or something else that's similar?
It's a really good question. When would you use a tuple versus a list? When you want to program defensively, or in general when you know that the values in this variable shouldn't change. So why would you use a data type that allows them to be changed? It just invites mistakes, bugs down the line, either by you or colleagues who are interacting with your code. So tuple is just another way where you can increase the probability of correctness by just not letting anyone, yourself included, change the contents therein. So it's just another tool in your toolkit. But let's make clear then what I mean by immutable. Again, I claim that immutable means that you cannot change the value. Well, let's go ahead and try to do this. Let me go ahead and run this program once more as is, Python of student.py. Let me go ahead and type in, for instance, how about Padma's name, and I'm going to go ahead and say that Padma's in Gryffindor, as in the movies, and we see Padma from Gryffindor. But technically, I went down this rabbit hole and looking at Harry Potter more closely, technically in the books, Padma, I believe, was from Ravenclaw. So this is actually a mistake or an inconsistency between the movies and the books. Let's see if we can't fix this inconsistency in our code. So how about we do this? If the student's name that's inputted equals Padma, why don't we override whatever the house is and change it to be properly Gryffindor? Let me go ahead and do if student. Now, if I want to get at Padma's name, I'm going to have to do student bracket 0. I have to know what location the name is in this tuple. But if that value equals Padma, let's go ahead with this if statement and make a change. Let's change the student's bracket 1 value. So the second value, if we're 0 indexing, let's change it to be another house in the world of Harry Potter called Ravenclaw. So I'm just fixing maybe the user's input. They watch the movie, so they type in Padma Gryffindor, but in the books, it was Padma from Ravenclaw. All right, let me go ahead and go down to my terminal window, clear my terminal, and do Python of student.py, enter. I'm going to do Harry as well as Gryffindor, just to demonstrate that that is still working as intended. Let me clear my screen again, though, and run Python of student.py on Padma, and I'll put her too in Gryffindor, as in the movies, and hit enter. And now I just see a big mess of errors on the screen. Some kind of exception has been thrown, and indeed, a type error has happened. I'm using a data type wherein there's an error. And what is that error? Well, tuple object does not support item assignment. It's a little arcanely expressed. That is, that's not really very user-friendly. But if you think about what those words mean, tuple object does not support item assignment. So assignment is copying from right to left. So somehow that's invalid. And here is a manifestation of the immutability of tuples. You cannot change location 0 or 1 or anything inside. That is a feature. That is the design of a tuple. So if I want to override that, I think I'm going to have to use a different type of data that we've used before, namely a list. And that's fine. If you want to enable yourself and colleagues using your code to change the contents of that container, well, we can go ahead and return not a tuple using explicit parentheses or no parentheses, just the comma, but I can use square brackets. And if I'm using square brackets on the left and the right, this is indeed explicitly a list. Same idea, but it's mutable. That is to say, you can change the contents of a list. So making no other changes, just returning a list with square brackets instead of a tuple with parentheses or just the comma. Let me go ahead now and run Python of student.py, enter. Let me type in Harry and Gryffindor again. That's still working. Good to see. Let me run this once more and type in Padma and Gryffindor, as in the movies, but no, now we've corrected it to be Padma from Ravenclaw, as in the books instead. Any questions now on tuples versus lists, or this idea of immutability versus mutability?
Can we use a nested tuple in Python, like a nested list?
Absolutely. You can have not only nested lists in Python, where one of the elements in a list could be another list. So you have some square brackets out here. You might have some other square brackets inside. You can absolutely do the same with a tuple as well. There's no constraint on the types of values you can put in there. We've not had occasion to do that in this case. I'm just returning a simple tuple with 2 elements. But yes, you could absolutely do that too. Other questions on tuples versus lists?
Okay, for example, when I say the square bracket, is it mainly used for the list?
Oh, a really good question. Sort of. So when you create a value like a list, you use square brackets, and that would indeed be a visual indicator that this is definitely a list. If you instead see parentheses, that's a visual indicator when creating a value that it's definitely a tuple. However, somewhat confusingly, both lists and tuples use square brackets when you access the contents of them. When you index into them at location 0 or location 1, you always use square brackets. So that's the distinction there. Good question. Allow me to propose now, if I may, that we solve this problem yet another way, and let's see if we're either making things better or for worse than us. Recall that dictionaries, or dict objects, also exist in Python, and a dictionary is this collection of keys and values. And the upside in particular of a dictionary is that they have better semantics, right? You don't just have to assume that a name is always going to be at location 0, house is always going to be at location 1. I mean, that's the kind of thing, especially if you had 3, 4, or more values, eventually you or someone is going to get confused and forget what the order is, and you're going to write buggy code. So a dictionary is a little more powerful in that you can semantically associate keys, like little descriptions with the values, those keys and those values respectively. So let me go ahead and do this, and we can do this in a few different ways, but let me propose that we focus on getStudent here. And let's go ahead and do this. Let me go ahead and delete the implementation of getStudent as is. Let me create a student variable and initialize it to an empty dictionary. And I can do that with just 2 curly braces here. And then let me go ahead and set 2 keys inside of that dictionary. Inside of the student, there will be, quote unquote, a name key. And the value of that is going to be whatever the return value of input is when I prompt the user for their name. And then the house key inside of that same student dictionary is going to be the return value of whatever the user types in for their house. And lastly, I'm going to go ahead and return student. So now I am literally returning one thing still, but this time it's a dict rather than a tuple, rather than a list. But there's still 2 things in it, technically 4 things if you count the keys and the values, but there's 2 key value pairs. Now my code up here is going to have to change a little bit. And let's simplify this and remove, for instance, now the Padma if statement, just to focus on what's changing at hand. And let me go ahead now and leave line 2 alone. I'm still going to have a student variable that gets assigned the return value of getStudent. But what I want to do here now is actually access the keys inside of that dictionary, not by numeric index, which was for tuples and lists, 0 and 1, but by way of their keys. Now, normally, I might be in the habit, as I personally am, of using double quotes, quote unquote name inside of there, and quote unquote house inside of there. But before I even run this code and show you a mistake, see an error on the screen, does anyone want to call out what I have done wrong here? This is just an F string. I just want to print out the value of the name key, the value of the house key in this dictionary, but your audio is a little garbled for us, but I think I heard double quotes and single quotes. So I'm going to assume that indeed you've identified precisely the issue. I'm just going to confuse Python right now. Even though this is an F string inside of double quotes prefixed with an F, I can't actually use my double quotes inside my double quotes because that's going to potentially confuse Python. Indeed, if I run this program now, Python of student.py, and hit enter, I get a syntax error. So the program didn't even run fully. It just couldn't be understood because it got confused by those double quotes. So the simplest fix here would indeed just be to use not double quotes, but single quotes around the keys. Or conversely, flip the double quotes on the outside to single quotes, then use double quotes on the inside. You just want to be consistent. So a subtle detail, but again, this is now specific to dictionary syntax. This isn't fundamental to how we're solving this current problem at hand. All right, well, let's go ahead and try this. Let me go ahead now and run Python of student.py. Let's go ahead and type in Harry. Let's type in Gryffindor. And hopefully, Harry is back from Gryffindor. No syntax errors, no other errors. I think I'm back in business here. And what I do like to be clear about using a dictionary is that it is allowing me just better semantics. Again, I don't have to remember, memorize, document that 0 is name, 1 is house. Instead, name is name and house is house. It's just a little clearer, a little more expressive. So that's generally a good thing, especially if we stored more data about students than just their name and their house. If you had 3 fields, 4, 5, 10 different fields, no one's going to want to remember or be able to remember forever which is 0, which is 1, which is 2, and so forth. Better to introduce names like name and house in this case. But let me tighten this up further. Indeed, I'm typically in the habit of not introducing variables unnecessarily unless they make the code more readable. And an alternative way to format the same code would be this. Strictly speaking, I don't need to create an empty dictionary, then add 1 key to it, then add a 2nd key to it, and then return that dictionary. I can actually consolidate this all into one statement, if you will. Let me go ahead and do this. Let me go ahead and say name equals inputs return value, house equals input's return value. And then instead of returning any variable named student, which I'm going to propose doesn't need to exist anymore, let me just create and return the dictionary all at once. Let me do quote unquote name in lowercase here, and then the variable, it's storing the user's name, then quote unquote house as my second key, the value of which is going to be house, the variable. Now, is this better? Maybe, maybe not. Maybe the first way was a little more readable, and that's totally fine to create variables if they improve the readability of your code. But just know that you can also create and return a dictionary on the fly like this, so to speak, all in one line. And I think it's arguably pretty reasonable in this case. Why? It's just pretty short. I probably wouldn't do this if it got longer and longer and longer. I might minimally then start moving my key value pairs to separate lines. But this would just be a slightly more compact way of doing this as well. But let me propose we do one more change. Let's go ahead and introduce that same special casing of Padma to fix her house, from Gryffindor, for instance, to Ravenclaw. How do we do this with dictionaries? Well, dictionaries, like lists, are mutable. You can change what is in them just like you can lists. How do you do that? It's just a little different syntactically. So let's go back into main and do this fix. If the student variable has a name key that equals Padma, then, indented, go ahead and change the value of the house key inside of that student dictionary to be, quote unquote, Ravenclaw instead. So very similar in spirit to what we did with a list, but instead of using location 0 and 1, we're much more clearly, explicitly, semantically using quote unquote name and quote unquote house, because you index into lists and tuples using numbers, but you index into dictionaries using strings, as I've done here. All right, let me go ahead and run Python of student.py. We'll again do Harry from Gryffindor, and I think all is well. Let me run it one more time, this time with Padma, who in the movies is from Gryffindor, but should really be from Ravenclaw. All right, any questions then on this progression from tuples to lists to dictionaries? We haven't necessarily introduced anything new other than those tuples, which have been available to us all this time. But the goal at the moment is just to demonstrate this distinction among these different data types and how they each work a little bit differently.
What if a combination of lists is there in a tuple? So is the list, like we can change the list because tuple are immutable, but lists are mutable?
Correct. You can change the contents of lists, and you can put most anything you want in them, other lists or strings, as I've done, integers or anything else. Tuples, you can do the exact same thing, but you cannot change them once you've created them. A dictionary is more like a list in that it is mutable. You can change it, but the way you index into a dictionary is by way of these keys, these strings, as we keep seeing, rather than by numbers, those numeric indices. All right, well, let me propose that there is yet another way of solving this problem. And indeed, I would argue that there's now an opportunity at hand. Even though this program isn't particularly complicated, all I'm doing is collecting a name from the user and a house from the user. You could imagine wanting longer term to collect even more information, like the student's Patronus or magical spell or a whole bunch of other information that might belong in a student. And right now, we're just kind of using these very general purpose data types in Python. A tuple to combine some values together, a list to do the same, but let us change it later, a dictionary, which is more powerful because it's a little more structured. It does have keys and it has values, not just values. But you know what? We wouldn't have to be having this conversation if the authors of Python had just given us a data type called student. Right? Wouldn't it have been nice if there were just a type of variable I could create in my code called student? Then we wouldn't have to figure out, well, do we use a tuple or a list or a dictionary? But that's pretty reasonable, right? You could imagine just how slippery of a slope that is, so to speak, if the creators of a language had to anticipate all the possible types of data that programmers like you and me want to store in your programs. So they just gave us these general purpose tools. But they gave us another general purpose tool that's going to allow us to create our own data types as well and actually give them names. And that terminology is a class. A class is kind of like a blueprint for pieces of data, objects, so to speak. A class is kind of like a mold that you can define and give a name. And when you use that mold or you use that blueprint, you get types of data that are designed exactly as you want. So in short, classes allow you to invent your own data types in Python and give them a name. And this is a primary feature of object-oriented programming, to be able to create your own objects in this way. And in the case of Python and classes, even give them some custom names. So what does this mean in real terms? Well, let me go ahead and come back to VS Code here. And let me propose that we introduce a little bit of new syntax. I'm going to go ahead and clear my terminal window first. I'm going to go to the top of my file, and I'm just going to start a thought but not finish it yet. I'm going to use this new keyword for classes called literally class. So indeed, the new keyword we're going to have here, and if I go back to our slides here, this would be the official URL where you can read up more on this particular feature of Python in the official tutorial. Class is a new keyword we can use. Now, this is coincidentally related to students, because students take classes, but it has nothing to do with the fact that we're dealing with students. Class is a general purpose term in a lot of languages, Python among them, that allow you to define these custom containers with custom names for pieces of data. So let's go back to VS Code. Let's use this new keyword. And let me propose that we create a class called student. And by convention, I'm going to use a capital S here. And I'm going to go ahead and, with a colon, get to later the implementation of this class. So I'm just going to use ... which is a valid placeholder for now. That just indicates to me that I'm going to come back to implementing this later. But as of now, it does in fact exist. I now have a student class defined for me that I can now use in my code here. How am I going to use it? Well, first of all, let me go down to get student, and let me change this code to no longer use a dictionary, but to use this class. I'm going to do this. I'm going to give myself a variable called student, as I've done before, but I'm going to set it equal to capital student, open parenthesis, close parenthesis. So I'm going to do what appears to be calling a function, and that function, student with a capital S, notice, matches the name that I gave this class at the top of my file. All right, what do I next want to do? I'm going to go ahead and give this student a name. Now, if I were still using a dictionary, I would say student, quote unquote, name using square brackets. But this is not a dictionary. It turns out classes have what for now we'll call attributes, properties of sorts that allow you to specify values inside of them. And the syntax for that happens to be a dot. We've seen dots before. We've used it in the context of modules and libraries more generally. This is another similar in spirit use of a dot that allows you to get at something inside of something else. So student.name is going to be the syntax I use for giving this student a name. And that name is going to be whatever the return value of name is. And then I'm going to go ahead and say student.house to give another attribute called house and give that the return value of input here, prompting the user for house. And then as before, I'm just going to return student. But now what's really powerful about class and object-oriented programming more generally is that I've created this custom data type called literally student, capital S. I've stored one such student in a variable, like I can always do in a variable called student, lowercase s, but I could call it anything I want. It just makes sense to call it student as well, but lowercase for clarity. And then I'm returning that variable. And because of my syntax in lines 14 and 15, that has the result of putting inside of that class a name attribute and a house attribute. I just need to make one more change up here. I'm going to go ahead and remove our Padma code just so we can focus only on what's new rather than fixing her house. And I'm going to go in here and change the syntax that previously was for dictionaries. Again, dictionaries use square brackets and then strings in quotes, either single quotes or double quotes, depending on the context. Here, though, I'm going to change this to be student.name. And over here, I'm going to change it to be student.house. And that's just going to be my new syntax for getting the contents of what appears to be a class called student. Let me go ahead and rerun Python of student.py, enter. Let's type in Harry's name as before. Let's put him in Gryffindor, crossing our fingers as we often do. And Harry is indeed from Gryffindor. What, though, have I done? Let's introduce one other bit of terminology here. It turns out that I can create a class using that class keyword, But anytime you use a class, you're creating what are called objects. And here is the word objects as in object-oriented programming, or OOP. Let me go back to my code here. And even though I haven't really implemented much of it at all, I literally just left it with a ... That's enough code, lines 1 and 2, to just invent a new data type called student, capital S, that may or may not have some future functionality as well. That's enough to create a class. What, though, am I doing on line 11? On line 11, what I'm technically doing is creating an object of that class. So this, too, is another term of art. You create objects from classes. So if we go back to that metaphor that a class is like a blueprint for a house, or a class is like a mold, an object is when you use that blueprint to build a specific house, or something that comes out of in plaster, the mold, when you actually use that mold to create such an object. So a class is, again, the definition of a new data type. The object is the incarnation of, or technically instantiation of. And another term for objects would actually be an instance. You have instances of classes as well. So that's a lot of vocabulary, but at the end of the day, it just boils down to this. You can define your own class, which is really your own data type. You can then store attributes inside of it using this dot notation here, and then you can access those same attributes using code like this here. And now I have a proper student data type, and I don't have to kind of hack something together using a tuple or a list or even a dictionary. I now have a proper data type called student that the authors of Python didn't give me, I gave myself. Any questions now on classes, this new keyword class, or this idea of these objects or instances thereof?
Is the class object mutable or immutable?
A good question, and we've clearly laid the stage for having that conversation about every data type now. We will see that they are mutable, but you can make them immutable. So you can get the best of both worlds now by writing some actual code. And we'll write more code than the ... in just a bit. Other questions on classes or these objects thereof?
Then what would be the properties of those classes?
So at the moment, the properties of, or the attributes of, as I've been calling them thus far, would just be name and house. It turns out that there may very well be other attributes built into classes that we may see before long. But for now, the only two attributes that I care about are the ones that I myself created, namely name and house are, again, what I would call attributes. And in a little bit, we're going to start calling those same attributes more technically instance variables. Name and house, as I've presented them here in VS Code, are really just variables called name and called house inside of an object whose type is student. All right, so what more can we do with these classes? Well, again, on line 11 is where we're instantiating an object of the student class and assigning it to a student variable. We're then adding attributes name and house respectively on lines 12 and 13 currently. Both of those have values that are technically strings or strs, because that's what the return value of input is. But those attributes values could actually be any data type. We're just keeping things simple and focusing on defining students in terms of two strings, name and house. And then on line 14, we're returning that variable. We're returning that object to main so that we can actually print out who is from what house. Well, let's go ahead and add a bit more functionality here, because right now on lines 12 and 13, this is a little manual. And it's a little reckless of me to just be putting anything I want inside of this student object. It turns out with classes, unlike with dictionaries, we can actually standardize all the more what those attributes can be and what kinds of values you can set them to. So let me go ahead and do this. Let me propose that it would actually be really nice if instead of doing this here, let me go ahead and simplify my code as follows. Let me go ahead and give myself a local variable called name and set it equal to the return value of input, like we've done many times now already. Let me give myself one other variable for now called house and set it equal to the return value of input as well, prompting the user for their house. And now, instead of creating a student object from my student class and then manually putting the name attribute inside of it and the house attribute inside of it, let me actually do something more powerful. Let me do this. Let me call that student function, which is identical to the class name. Just by defining a class, you get a function whose name is identical to the class name with the capital letter included. But instead of just doing open parenthesis, close parenthesis, let me pass in the name that I want to fill this object with and the house that I want to put in that object as well. And now let me set the return value as before to be student equals like this. So what have I done that's different? Fundamentally, I'm still getting user input in the same way. I'm using input on line 11 and input on line 12, and I just so happen to be storing those return values in local variables. But now we're setting the stage for the more powerful features of classes and object-oriented programming more generally. Notice that I'm deliberately passing to this capital S student function name, comma, house. I'm passing in arguments to the function. Now, the student class is not going to know what to do with those yet, but now I'm sort of standardizing how I'm passing data into this student class. And ultimately, it's going to give me an opportunity to error check those inputs to make sure that the name is valid, that it has a value, and it's not just the user hitting enter. It's going to allow me to ensure that it's a valid house, that it's Gryffindor or Hufflepuff or Ravenclaw or Slytherin, or not just hitting enter or some random value that the user types in. Because I'm passing name and house to the student class, this particular function, I'm going to have more control over the correctness of my data. So let's now go up to the student class, which up until now I left as just ... It turns out that in the context of classes, there are a number of not just attributes or instance variables that you can put inside, but also methods. Classes come with certain methods or functions inside of them that you can define, and they just behave in a special way by nature of how Python works. These functions allow you to determine behavior in a standard way. They are indeed special methods in that sense. Now, what do I mean by this? Well, let me go back to VS Code here, and let me propose that I start to define a standard function called underscore underscore, or dunder as it's abbreviated, init underscore underscore. And then I'm going to go ahead and do open parenthesis. And then I'm going to put in here literally the word self. More on that in just a moment. But now inside of this function, I'm going to have an opportunity to customize this class's objects. That is to say, this underscore underscore init method, or dunder init method, is specifically known as an instance method, and it's called exactly this. This is designed by the authors of Python, and if you want to initialize the contents of an object from a class, you define this method, and we'll see what it's about to do here. Let me go back to VS Code, and let me do something like this. Self.name equals name, and self.house equals house, but I don't want to just init this object very generically. I want this method called init to take in not just self, but name, comma, house as well. Now, what in the world is going on? Because there's a lot of weird syntax here. There's this dunder init method, double underscore, init, double underscore. There's all of a sudden this parameter called self, and then there's this new syntax, self.name and self.house. Now you're seeing really a manifestation of object-oriented programming. It's not all that different fundamentally from what we've been doing for weeks with dictionaries by adding keys to dictionaries. But in this case, we're adding variables to objects, aka instance variables to objects. Now, what's going on? Let's do this in reverse. Let's go back to the line of code we wrote earlier. On line 15, I am treating the name of this class, student with a capital S, as a function. And I am passing in two values, name and house. What I've highlighted here on the screen on line 15 is generally known as a constructor call. This is a line of code that is going to construct a student object for me. Using synonyms, it is going to instantiate a student object for me. And again, how is it going to create that object? It's going to use the student class as a template, as a mold of sorts, so that every student is structured the same. Every student is going to have a name. Every student's going to have a house. But because I can pass in arguments to this student function, capital S, I'm going to be able to customize the contents of that object. So if you think about the real world, if you've ever been on a street or a neighborhood where all of the houses kind of look the same, but they might be painted differently, they might be decorated a little bit differently on the outside, all of those houses might have been built using the exact same blueprint, sort of a mold, if you will, but then you can specialize exactly the finer points of those houses by painting the outside a different color or planting different trees. You can style them differently. Similar in spirit here. We have a student blueprint that's always going to have now a name and a house, but it's up to you and me to pass in any name and any house that we want. Now, where is this function? The fact that I'm calling student, capital S, and then a parenthesis and a close parenthesis with arguments inside suggests that there's a function somewhere in the world that has been defined with def that's going to be called. Well, as you might have guessed by now, the function that will always be called by definition of how Python classes work is a function called _init _. Why? It's a crazy name, but it's what the authors of Python chose to just implement the initialization of an object in Python. Now, the only weird thing, especially weird thing, I will admit, is this. It would be way clearer to me, too, if the only two parameters for init were just name, comma, house, right? That's how we've defined every function thus far in the class. You just specify the parameters that you want the function to accept. And indeed, that lines up with what I'm doing on line 15. I am only passing in two things to the student function. But it turns out that the authors of Python need to give us a little bit of help here. Because suppose that you pass in name and house to this init method, and a method is just a function inside of a class. What are you going to do with the name and the house? Like literally, where are you going to put them? If you want to remember the name and the house for this student, you've got to be able to store those values somewhere. And how do you store them in the current object that has just been instantiated? Well, the authors of Python decided that the convention is going to be that this init method also semi-secretly takes a third argument that has to come first. By convention, it's called self, but you could call it technically anything you want. But the convention is to always call it self. And self, as its name implies, gives you access to the current object that was just created. What does that mean? Again, now on line 14, now that it's moved down a little bit, this line here is a constructor. It constructs a student object. But there's nothing in that object initially. There's no name, there's no house. But the object exists in the computer's memory. It's up to now you to store the name and the house inside of that object. How do you do that? Well, Python will just automatically call this init method for you. And it's going to automatically pass in a reference to an argument that represents the current object that it just constructed in memory for you, and it's up to you to populate it with values. And what this means is that inside of your init method, you can literally do self.name to create a new attribute, aka an instance variable, inside of that otherwise empty object and put this name inside of it. It allows you to do self.house and store that value of house. Now, you could call these things anything you want. They could be n, they could be h as before, but that's really not very self-explanatory. Much better to do this kind of convention, self.name equals name, self.house equals house. And this is like installing into the otherwise empty object the value name and house, and storing them in really identically named instance variables in the object. And again, an object is just an instance of a class. Now, I know that was a lot of vocabulary. That's a lot of weird syntax. So any questions on this init method, whose purpose in life, again, is to initialize an otherwise empty object when you first create it?
So what is the difference between the init method and default constructor?
A good question. So in other languages, if you programmed before, for instance, Java, there are functions that are explicitly called constructors that indeed construct an object. They initialize it with values. Python technically calls this init method the initialization method. It initializes the value. It's on line 15 now of my code. If I scroll back down, that I'm technically constructing the object. It turns out there's another special method in Python that we won't talk about in detail today called __new __ that actually handles the process of creating an empty object in memory for us. But generally speaking, you, the programmer, don't need to manipulate the new function. It just works for you. Instead, you define your own init method here, an init function inside of your class. And that method initializes the contents of the object. So there's technically a distinction between constructing the object with new and initializing it with init. But in the world of Python, you pretty much only worry about the init method. Python generally does the other part for you. A good question. Others?
What about if you want to store more than one name or more than one house?
A good question. If you want to store more than one name or more than one house, you can do this in different ways. You could create other attributes technically called instance variables, like self.name1, self.name2. But we've seen in the past that that is not a very good design just to have multiple variables to store multiple things. Maybe instead you have an instance variable called self.names, plural, and you set it equal to a list of names or a list of houses. Now, in this case, I don't think that really solves a problem because I'm trying to implement a student, singular, so it doesn't really make sense to have multiple first names, maybe a nickname, maybe a last name, so we could add those too, but I don't think we need multiple names per se, and in this case, multiple houses. But absolutely, you could do that using some of our familiar building blocks like lists. Other questions?
How are classes or objects represented in memory?
How are classes and objects represented in memory? So the class is technically just code. It is the code on the top of my file, lines 1 through 4, that defines that blueprint, that template, if you will. Objects are stored in the computer's memory by taking up some number of bytes. So you're probably familiar with bytes or kilobytes or megabytes. There's some chunk of bytes, probably all in the same location in the computer's memory or RAM, where those objects are stored. But that's what Python, the program, handles for you. Python, the interpreter, figures out where in the computer's memory to put it. You and I, the programmers, get to think and solve problems at this level. Python, the interpreter, handles those lower level details for you. How about one final question on classes and objects?
Now my question is, if we can do the same thing with the dictionary, so why to use classes?
Good question. If you can do the same things as you can with dictionaries, why should you use classes? Because we are just scratching the surface now of what you can do with classes. Allow me to go back now to my keyboard and show you more of what you can do with classes. But in short, you can do much more with classes. You can ensure the correctness of your data much more with classes. You can error check things. And generally, you can design more complicated software more effectively. And we'll continue to see today features of Python and object-oriented programming more generally that allows us to do just that. So let me propose, in fact, that first, let's just tighten up this current implementation, which again has us with an init method that just declares two instance variables, self.name and self.house, which again just creates those variables inside of the otherwise empty object and assigns them values, name and house respectively. Let me go ahead and just do one little thing here. I don't really need this student variable. Let me just tighten this up so that each time we improve or change the code, we're focusing really on just the minimal changes alone. So I've not fundamentally done anything different. I just got rid of the variable name, and I'm just returning the return value of this student function that's constructing my new object for me. So I'm just tightening things up as we've done many times in the past. Well, what if something goes wrong when in creating this student? For instance, what if the user does not give us a name and they just hit enter when prompted for name? Like, I don't want to put in my computer's memory a sort of bogus student object that has no name, right? I'd ideally like to check for errors before I even create it so I don't create a nameless student. It would just be weird and probably a bug to have an object that has no name. Similarly, I don't want the user to be able to type in something random as their house. At least in the world of Harry Potter, there's really only 4 houses, at Hogwarts at least. Or there's, again, Gryffindor and Hufflepuff and Ravenclaw and Slytherin, a list of 4 valid houses. It would be nice if I somehow validated that the user's input is indeed in that list. Now, I could do all of that validation in my getStudent function. I could check, is the name empty? If so, don't create the student object. Is the house one of those 4 houses? If not, don't create the student object. But that would be rather decoupled from the student itself, right? GetStudent currently exists as just my own function in my student.py file. But classes, and really object-oriented programming more generally, encourages you to encapsulate inside of a class all functionality related to that class. So if you want to validate that a name exists, if you want to validate that a house is correct, that belongs just fundamentally in the class called student itself, not in some random function that you wrote elsewhere. Again, this is just methodology. Because again, if we think about writing code that gets longer and longer, more and more complicated, it should make just intuitive sense that if you keep all the house and all of the name and all of the house related code in the student, it's just better organization, right? Keep all of the related code together, and that's probably going to set you up for more success. And indeed, that's part of this methodology of object-oriented programming. Let me go ahead now and change my students classes init method to do this. If the name is blank. So if not name, and we've seen this kind of syntax before. If you say in Python, Pythonically, if not name, that's like doing something like this. If name equals quote unquote. But I can do this a little more elegantly, just say if not name would be the more Pythonic way to do it. Well, I want to return an error. Like I might want to do something like this, print missing name. But this is not good enough. It does not suffice to just print out missing name and then let the rest of the code go through. All right, well, what could I do instead? In the past, we've seen another technique. I could do sys.exit, and I could say something like missing name, and I could go up here and I could import sys. But this is a really obnoxious solution to the problem. Just because you, or maybe a colleague, messed up and called a function with an invalid name, you're going to quit my whole program? Like, that's really, really extreme of a response. And you probably don't want to do that if your program's in the middle of running. You might want to clean some stuff up. You might want to save files. You don't want to just exit a program sometimes in some arbitrary line just because input was invalid. So I don't think we want to do that either. But we do now have a mechanism for signaling errors. Unfortunately, I can't do something like this. I could try returning none and say, this student does not exist. I'm going to hand you back none instead. But it's too late. If we scroll back down to where I'm creating the student, it's on line 17 now where I've highlighted this code. The student has already been created. There is an object somewhere in the computer's memory that's structured as a student. It just doesn't have any values inside of it. But it's too late, therefore, to return none. That ship has sailed. The object exists. You can't just suddenly say, nope, nope, there is no object. There is an object. It's up to you to signal an error. And how do you signal an error? Well, we've actually seen this before, but we haven't had occasion to create our own errors. It turns out in Python, there's another keyword related to exceptions that Python itself uses to raise all of those exceptions we've talked about in the past when you've caught things like value errors or other such exceptions that come with Python. Well, it turns out you, the programmer, can raise, that is, create your own exceptions when something just really goes wrong. Not wrong enough that you want to quit and exit the whole program, but enough that you need to somehow alert the programmer that there has been an error, something exceptional in a very bad way. Something exceptional has happened, and let them try to catch that exception as needed. So let me go back to VS Code here and propose that if the user passes in an invalid name, it's just empty, so there's not a name. Well, what I really want to do is this. I want to raise a value error. And we've seen the value errors before. We've created value errors accidentally before, and generally you and I have tried to catch them if they happen. Well, the flip side of this feature of exceptions in a language like Python is that you, the programmer, can also raise exceptions when something exceptional happens. And you can even be more precise. You don't have to raise a generic value error and let the programmer figure out what went wrong. You can treat value error and all exceptions in Python like functions and actually pass to them an explanatory message like, quote unquote, missing name. So that at least the programmer, when they encounter this error, knows, oh, I messed up. I didn't make sure that the user has a name. And now what do you want to do instead? Well, now if you're the programmer, you could do something like this. You could try to create a student, except if there's a value error, then you could handle it in some way. And I'm going to wave my hand with a ... at how you would handle it. But you would handle it using try and except, just like we have in the past. And that would allow you, the programmer, to try to create the student. But if something goes wrong, OK, I'll handle it nonetheless. So what's new here again is this raise keyword that just lets you and I actually raise our own exceptions to signal these errors. Well, let me go back to my code here. And I'm just going to go ahead and not bother trying or catching this error. For now, we'll just focus on raising it and assume that from our week on exceptions, you could add try and except as needed in places. Let me go back to the code here and propose that something else could go wrong with house. Right? If there is a name, we're good. But if we're given a house but it's invalid, we should probably raise an exception for that too. So what if we do this? If house is not in the list containing Gryffindor, quote unquote, Hufflepuff, quote unquote, let's see, Ravenclaw, quote unquote, or Slytherin, quote unquote, then with my colon, let's raise another type of value error. But rather than raise a generic value error, let's pass in an argument, quote unquote, invalid house. And so here we now see a capability that we can do with classes that we can't with dictionaries. If you add an attribute to a dictionary, a key to a dictionary, it's going in no matter what. Even if the name is empty, even if the house is a completely random string of text that's not one of these 4 houses, it's going into that dictionary. But with a class, and by way of this init method, you and I can now control exactly what's going to be installed, if you will, inside of this object. You have a little more control now over correctness. And so now let me go ahead and scroll back down to my terminal window and clear it. Let me run Python of student.py. Let me type in something like Harry. Let me type in Gryffindor, enter, and we see that indeed Harry is from Gryffindor. What if I made a mistake, though? What if I ran Python of student.py and typed Harry as the name, but I this time typed in number 4 Privet Drive, which is where he grew up, instead of his proper Hogwarts house? Let me hit enter now, and now you see a value error. But this isn't one that Python generated for us per se. I raised this error, and therefore, if I went in and wrote more code in my getStudent function, I could also catch this error with our usual try except syntax. So all we have now is not just classes in our toolkit, but even more powers when it comes to exceptions, and not just catching them ourselves, but raising them ourselves too. Any questions now on this use of classes and init, and now this ability to raise exceptions when something goes wrong inside of the initialization?
So what if the user has a middle name, middle name, and last name? How would you fix that?
A good question. If you wanted the student to have a first name, middle name, and last name, we could do this in a bunch of different ways. The simplest, though, let me clear my screen here, and let me just temporarily do this. Let me propose that the init method take in a first argument, a middle argument, and a last argument. And then what I think I would do down here is ultimately have first equals first, and then I would do the same thing for middle and last. So middle, and then last and last. And then what I would have to do here is when I actually ask the user for their name, I might need to really go all out. I might need to ask them first for their first name and store that in a variable called first, and therefore pass in first. I might similarly need to ask them for their middle name and store that in a variable, and then pass in a second argument middle. And then lastly, if you will, let me go ahead and create a third variable called last, get the input for their last name, and pass that in as well. I could instead just use one input and just ask them for their whole name. So type in David Malan, enter, or David J. Malan, all 3 of them. And maybe I could use Python split function, maybe a regular expression to tease it apart. That's probably going to be messy, because there's going to be people who don't have just 2 or 3 names. They might have 4 or 5. So maybe sometimes it's better to have multiple prompts. But that's not a problem, because with a class, we have the expressiveness to take in more arguments if we want. We could even take a list if we wanted. But I think we'd probably want to have even more error checking then, not just for name, but for first, and then maybe for middle, and then maybe for last. So it just is more and more code, though there would be ways to perhaps consolidate that too. Let me undo all of that and see if there are other questions now on classes.
I assume this is classes are something I might do at the beginning of a project. Can I just put them in a different file and import them into my project or my main code as needed?
Absolutely. A really good question. You could imagine wanting to use this student class not just in student.py, but in other files or other projects of yours. And absolutely, you can create your own library of classes by putting the student class in your own module or package, per our discussion in the past about libraries more generally. And absolutely, you can do that. And later today, will we see that we've actually been using classes, you and I, before in third-party libraries. So you, too, can absolutely do the same. How about one more question on classes?
Can you have optional variables in classes? And 2, can you have your own error names? Like, let's be egotistical and say, I want to raise Eric error.
Short answer, yes. So you can, these init functions are just like Python functions more generally, even though they're special in that they're going to get called automatically by Python for you. But if you wanted to make house optional, you could do something like this. You could give it a default value in the init function's signature, so to speak, in that first line of code on line 2, and that would allow me to not have to pass in house. In this case, I'm going to continue to always pass in name and house, but you could make things optional. And yes, to your second question, if you wanted to have your own error message, like an Eric error, you could actually create your own Eric error exception. And we'll see in a little bit that there's actually a whole suite of exceptions that exist, and you too can invent those as well. Let me propose, though, that we now introduce one other aspect of this whereby we try printing out what a student looks like. At the moment, if I scroll back down to my main function, I'm still printing the student's name and house very manually. I'm going inside of the object, doing student.name, and I'm going inside of the object again and getting student.house just to see where the student is from. But wouldn't it be nice if I could just print the student like I've been printing for weeks, any int or float or stir or any other data type? Well, let's see what happens if I just try printing the student instead of manually going inside and trying to create that sentence myself. Well, in my terminal window, let me go ahead and run Python of student.py again. Let me type in Harry. Let me type in Gryffindor. And voila, Harry. Whoa. OK, main student object at 0x102733E80. Well, what is going on? Well, if you were to run the same code, you might actually see something different on your computer in terms of that number. But what you're really seeing is the underlying representation as a string of this specific object. In particular, you're seeing where in the computer's memory it is. This number 0x102733E80 refers to essentially a specific location in the computer's memory or RAM. That's not really that interesting for me or you, or generally speaking, programmers, but it's just the default way of describing via print what this thing is. But I can override this as well. It turns out that there are other special methods in Python when it comes to classes, not just underscore underscore init underscore underscore, but continuing in that same pattern, underscore underscore stir underscore underscore. So this too is a special method that if you define it inside of your class, Python will just automatically call this function for you anytime some other function wants to see your object as a string. Print wants to see your object as a string, but by default, if you don't have this method defined in your class, it's going to print out that very ugly esoteric incarnation thereof where it says main.studentObject at ox ... Well, how can I then define my own stir function? Well, here back in VS Code, let me propose that I go in and define not just underscore underscore init, but let me define a second function in this class here as follows. Def underscore underscore stir underscore underscore. There are indeed two, even though the font in VS Code is putting the two underscores so close, it just looks like a longer underscore. There are indeed two there on the left and the right, just like for init. This one only takes one argument that by convention is always called self, so that you have access to it. And then indented below that, after a colon, I'm going to go ahead and create a format string and return it. So let me go ahead and return, how about something generic first, like a student. So I'm not going to bother even trying to figure out what this student's name or house is. I'm just going to always return a student. Let me go back now to my earlier code, which has print student on line 16. Let me clear my terminal window and rerun Python of student.py, enter, type in Harry, type in Gryffindor. Last time I saw that very cryptic output. This time I see more generically a student. You know, more readable, but not very enlightening. Which student is this? Well, notice that the double underscore stir method takes in this self argument by default. It's just the way the Python authors designed this method. It will always be passed a reference to the current student object. What do I mean by that? When this line of code on line 6 is called, print, because it's hoping it's going to get a string, is going to trigger the underscore underscore stir underscore underscore method to be called. And Python for you automatically is going to pass into that method a reference to the object that's trying to be printed so that you, the programmer, can do something like this. Here's an F string with double quotes as usual. I'm going to use some curly braces and say print out self.name from self.house. So there's nothing new in what I've just done. It's just an F string, an F on the beginning, two double quotes, a couple of pairs of curly braces. But because automatically this stir method gets past self